Hello world and welcome to this new tutorial. My name is Nelson Fojo, and in today's video we are going to be solving the last section of this CASPA Inter-Regional Mock 2024, which is programming. So without wasting any time, if you haven't yet watched the previous video, do well to do that, because this is the third video in a series of 3 and we are completing the paper. If you haven't yet subscribed to the channel, do well to subscribe and share for more content to be created in the Nelco Explains Computer Science and ICT YouTube channel. Good. We're going to dive in directly into the question paper, and as usual, begin with our short notes and work directly. So this question paper had tax A database 25 marks. It has been completed already. Watch the video in the following the link in the description below. Tax B spreadsheet 20 marks has been completed also. The link is also found in the description below. And in today's video we are going to be doing the tax C programming, which is the last one, 10 marks. So we are not going to waste a lot of time here. As prerequisite materials, you need first of all the question paper itself. You can download that by visiting the website www.gcrevision.com by following the link in the description of this video. Alright, so let's get started with the short notes. We're going to start with important definitions as usual that will help you in navigating the question paper and understanding the basic concepts as far as programming is concerned. So we'll start with important definitions. The first definition we're going to say is an algorithm, which is a step-by-step procedure for solving a problem or performing a task. It provides a clear set of instructions to achieve a specific result. Next, we have a pseudocode. This is an informal-like description of an algorithm that can be made use of strict syntax rules and of any programming language. Next, we have a computer program, which is also called software or just a program. It's a sequence of instructions written to perform a specified task with a computer. Next, we have a programming language, which is the language that is used for creating computer programs. And we have a control structure, which is one that specifies the manner in which statements are executed in an algorithm or program. Now let's look at types of control structures. The first control structure we have here is a sequential control structure, which are instructions which are executed one after another in any order they appear in the program. The key characteristics of sequential control structures are they are the default control structure and there is no decision making or looping operations here. Let's look at an example. Print step 1 starts, print step 2 calculations, print. Okay, so this is just a pseudocode that shows how the sequential control structure goes. Now the use case of sequential control structures is when tasks need to be executed in a linear manner, such as displaying a message or performing basic calculations. The next control structure we're going to look at is the selection or decision-making control structure, which allows the program to make decisions and execute certain blocks of code based on conditions. Let's look at the types of selection control structure. The first one is the if statement, which executes a code if the condition is true, and the if else. Next one is the if else statement, which executes one block of code if the condition is true and another is false. Next, we have an if else statement, which handles multiple conditions. Like we have an if statement, we have an elif, which means else if, and the final condition if all the other ifs are not met is the else. Alright, another type of selection control structure that you might see in algorithms is a switch or the match statement. It's usually language dependent, meaning in any language it has its format, which chooses between many options and switches. Next, we have the selection. You see on the selection or decision making control structure. Let's look at the use case of this control structure. It is when you need to perform different actions based on conditions, such as validating user input or making decisions. Let's look at an example. You have if bracket the condition, with the brackets open, you put the code to execute if the condition is true here, and the else, the code to execute here if the condition is false. So it first of all checks for the true condition in this block of code, and if else it's not satisfied, it comes here directly. This is a typical example of a selection control structure in any programming algorithm you're going to have. Next control structure we're going to look at is the iteration or looping control structure, which executes a block of code repeatedly based on a condition. So the keyword here is repeatedly executes a block of code. Okay, let's look at the types. The first one is the for loop, which iterates a specific number of times over a collection. Next, you have a while loop, repeats a condition if it is true, and the do while loop. Now let's look at the do while loop. A language dependent, meaning some languages they have their own format, others have different formats. It executes a block of code at least once before checking the condition. Alright, now let's look at the use case of the iteration control structure. When tasks need to be repeated, such as processing lists, counting, or performing repetitive calculations. So these are basic usage cases for the iteration control structure or the looping control structure. Let's look at the examples. You have the for loop. The for loop in the C programming language, the first one is you have to initialize. The initialization, like where should your counter variable start, the condition that should be met for this loop to continue going, and the incrementation. Do you want your loop to be going one step after the other, or 2 steps, or 3 steps? It depends on you. So this is the syntax. Any C programming language iterative control structure block of code. The next is the while. To use a while loop, you have while in bracket, you put your condition here, like for example, while the number inputted by the user is less than a certain number, like 5, this block of code should execute. And the last iterative control structure we're going to be seeing is the do while loop. It does the condition, it does the operation, before checking the condition. So it does this specific block of code before checking the condition, whereas the while loop checks the condition before executing the code. So this one will go one more time than this, because this will always execute before the condition is checked. Okay, that's it. Let's look at the C skeleton. Whenever we are going to be dealing with programming questions, you always see this block of code, and I'm just going to explain each part as clearly as I can, and we are going to see that more in the practical section. So the first thing you should know is, before starting any C code, you need a library. A library is simply a kind of container that stores different functions in C programming. Here you have the hashtag include stdio.h, which means hashtag include standard input output .header, which is a basic function, a basic library that is predefined in your C programming syntax, and always comes with the IDE. IDE stands for Integrated Development Environment, which is the app or the software we're going to be using to run and compile our C codes. Now you have the int main, which is the main function that tells you that anytime you want to start with this function. And next you have the printf function, printf hello world inside the brackets, and the quotes or statement ending with semicolons. Before you use this printf, you must include this library, because this library stores the printf function and the scanf function. The printf function prints this word to the terminal. That means if you want any output, you should use the printf function, and you're going to output this for the user to see. And another function that is included in this library is the scanf function, which takes input from the user. We're going to see that more in the upcoming videos. And now you have return 0 here to tell the program that it's okay, all the statements have been executed, and you can stop. So this should be the last in your main function before closing your curly brackets. And now here you have comment. All double slashes, anything that come after a double slash in C, is considered as a single line comment. We're going to see another type of comments, the multi-line comments, in the upcoming videos. So one thing you should know here is, this is the basic skeleton, and I want you to master this. Print, like, just recopy this in your IDE and let your first program be a hello world, which is going to be displayed to your terminal. All right, now let's look at arrays. One thing you should know is an array, or let's start with a one-dimensional array, is a collection of elements of the same data type stored in contiguous memory locations. It can be thought of as a list of items. When you have a list of items of the same data type, maybe the same numbers, not the same, but let's say integers here, a group of members of items belonging to the same family, considered as an array. Let's look at the syntax of arrays in C programming. In the C language, you have the syntax. The first thing is the data type. You need to initialize the data type first. Different data types we need to consider here are, you have the integer, int, the decimal, float, the text, which are strings. So we're going to see how to initialize them in the upcoming videos. Next, you have the array name. The array name, like your list is a list of students, a list of numbers, so you have a name for that. You place it here, and in the square brackets you put the size, meaning how many elements should be put in that list. And you always conclude with semicolon. All statements in C ends with a semicolon. Next, let's look at this example. Int numbers 5. Here I have just declared an array of 5 integers. This is how you declare an array, meaning this is an empty list of 5 items which is made just of integers. Now let's see how we can initialize it. To initialize an array, meaning to fill elements into the array, you have int numbers 5, you put equal to sign. Inside curly brackets, you put the values 1, 2, 3, 4, 5. That means this array now contains a list of numbers from 1 to 5. You have initialized it, and also you can also initialize arrays without their size. Like C can understand that if you have initialized already, it just counts and knows that yeah, this is an array of 5 elements. You can leave it empty if you wish. Next, let's visualize now how arrays function in C language. In the C language, let's say this is our list made up of items 1, 2, 3, 4, 5. One thing you should note is all of them are accessed in the machine through indexes. An index is simply position to a specific item. This could be a list of other items like 5, 7, 17, -6, or 20. Yeah, all integers. Now, how we see know that this guy is at which position? Now, the positions, you wouldn't obviously think that is 1, 2, 3, 4, 5, but here indexes are positions minus 1, meaning this first element is accessed by taking its index location, which is at index 0. The second element is at index 1, the third element index 2, and so on. So the number of elements is equal to the index number is equal to the position, like as we usually know in normal counting, minus 1. So the fifth element here will be at index 4, the first element index 0, as we just saw. So let's look at an example. You have a printf function, %d inside quotes, comma, numbers 2. What I'm doing here is I am calling this particular element of my array at index 2, and I am putting him here. That's how you map out format specifier to the specific printing. Like in the other example, we just printed hello world. We said printf in quotes to put hello world. But now what if you want to print a variable and we don't want it to appear like the name of the variable? Here we are using what we call a format specifier to tell us that here we are calling map. We are mapping out to an integer. Format specifier for integers is %d. Float for decimals, format specifier is %f, and for characters %c. So we are going to look at it more in the upcoming videos. So here you are going to see the output will be 3 because element at index 2 in the numbers array is 3. So anything put inside the curly brackets at this position whenever we are calling them at their index numbers. Please take note, the index numbers, because we're going to see that as we're going to be solving the question paper itself. Alright, so that said, I believe you have copied all the short notes and understood to your maximum. Let's now take it practical and answer the question paper. Alright, so as usual, first thing to do whenever you're attacking the question paper is to go through the whole questions, so as to know exactly what you should be doing and not missing out for the next upcoming questions. Right, so like C programming is 10 marks, and it says description of task. The program requests for the radius to calculate the area of a given circle. Here you have the Pascal code. We're not going to be using Pascal in this video. We're going to be using the C code. So hashtag include stdio.h. Yeah, that means you're going to be using the printf and the scanf function, the int main, and the return 0 to close the main function. So what we should focus on is this block of code inside here. Alright, so we have int ij. Here we are initializing, declaring. So we are declaring the two variables. Here we are declaring an array. The name is a, and it is of size 10. That means this array takes just 10 integers. Now we have our loop. For I equals to 0, initialization, I less than 10 condition. Oh, I plus plus, incrementation of the counter variable. So here it's supposed to be I. We're going to fix that. Now inside the for loop, what happens? A of I, meaning I will go from 0, 1, 2, 3. Same thing here is equals to this. But now we know that the indexes of 10 elements will leave from 0 to 9. So A of 0 will be equal to 0 plus 1, because when I is 0, I is also 0 here. 0 plus 100, that will be 100. So 101, 102, 103. Okay, so it's going to do that 9 times or 10 times, because 0 to 9 is 10 times. It's going to fill this array. This is initialization inside the loop. So it's going to fill this array. A of 0 will be 100, A of 1 will be 101, A of 2 will be 102. So all the positions of the elements in this array will be filled out. A of 0 to A of 9. Yeah, and all the 10 elements will be listed out from 100 to 109. Okay, now the for loop is a different one here. It is not nested. So the first for loop is like initializing. The second for loop, for j equals to 0, j less than 10, j plus plus, 0 to 9, as you know, because any number less than 10 here will be 9. You can't execute for 10 because 10 is not less than 10. 10 is equal to 10. Let's understand what happens in this block of code as far as the for loop is concerned. You have printf, element %g, comma specifier. That means it should map out to something. It maps out to the first variable, which is j, equal to %g, \n. This \n means go to the next line. Like after printing it, print it to the next line. So you're going to have the first element, second element, printed on top of the other. So here we have %g and %g. This first one maps out to j, which is the index position, 0, 1, 2, 3, 4, 5, 6 up to 9. So we are calling element of %g. So here there is another problem because there is no array here. Don't forget our syntax. Whenever you're calling for an array, the name should be there first. So we're first going to type this here and see if we're going to have any error. If not, it's correct. A of j, that means this next %g equals out to A of g, and this is the j we are talking about. The index positions, we are trying to print it out because we already filled it. A of 0, A of 1, they have values. So these ones are just variables. Variables that stores is a container that stores a value. Here they're just being declared, whereas here they're initialized to 0, 1, 2 up to 9. Same thing as here. So they'll be substituted here to their corresponding numbers. Question 1 says type and run the one of the code above, the code using the appropriate compiler. Save the program as task 3. Right, you're going to do that. Compile the code and make sure that there is no typing error. Alright. Question 2. What does the program do? Alright, we're going to explain that. State and define control structures, those in the program above. Print screen the output and save as screenshot. Alright, so now that we have gone through the question paper, we go back to the first question. Type and run one of the above codes using the appropriate compiler. Save the program as task 3. Okay, so we are going to invite our IDE to come and work. We have 2 IDEs to perform that. We're going to choose one of them. The first one is dev C++, which is an IDE that can run C codes and C++ codes, while CodeBlocks is a more developed IDE which can be used to run and compile more programming languages. So we are going to use CodeBlocks in this tutorial. I'm going to show you how to open your CodeBlocks and start writing down all your code. So while it's opening, one thing that I want to tell you guys is whenever you see this type of question, do not be afraid. Just take your time and go line by line, understanding each part exactly as it is given, and don't try to do everything at once. Take it once after the other, then at the end try and take the remaining time to go through your work. Alright, so to begin our code, we're going to click on create a new project, and we are going to go to course files. We're going to put C/C++ source to tell this IDE that we are dealing with the C code. We choose the C, press on next, then file name or full part, you press on this 3 dots to tell exactly where you want to solve it to save your work. So we are going to redirect it to our candidate folder, and we are going to put the file name tax 3, and it's okay, it's already recognized as C file. Okay, tax 3. Alright, So after that, you press save and finish. Good. So our IDE is open. We have taxi.c here. Don't need this for now. Okay, we need to start here. Let me first introduce you to the IDE. Whenever you want to start a new file, you can just come to file, new, empty file before renaming it. After, you could open a file that you already have, and here this is where you build, this is where you run, this is where you build and run. So another name for building could be compile. All right, so that said, we're going to type exactly what is written here, exactly as it is written first, and try to debug. Like if there's any error, we'll fix that. Good. So we start. Hashtag include stdio.h, okay, which is a standard input output dot header. Okay, our next line is the int main, which has some brackets. Now open our curly brackets, set our curly bracket. The IDE indents automatically for us, so we declare our variables I and j. In our statement, declare our array int a, and insert our array with square brackets and the size of 10. Must end every statement ends with a semicolon. Now we initialize our loop for I equals to 0. We state the condition I less than 10, and we give the increments. The increment there is 1 plus plus. We are going to check that it's a mistake, but yeah, I'm going to fix that. We open our curly brackets. You could open it after or before, it depends on you. So let's just do as the code says, a similar indentation. So right here we say a of I is equal to 1, I plus 100. We end with a semicolon. We out of the loop, we start a new for loop with a new implementation. We say for j initialization equal to 0, condition j less than 10. Because you can see here there's no mistake, because it says very well that j plus plus, meaning increment j by 1. J plus plus means j is equals to j plus 1. That is the same thing. So we go to the next line, come back here, now curly bracket and close, indentation automatic. Okay, let's just say print printf. Yeah, printf. You don't say print in C, you say printf. And we open our quotes. We say element. Okay, there's no name for the array. Let's just put that. We're going to fix that. But the ratio is going to give us an error. Percentage z, put it back as it is. We say equal to, maybe the code was put like intentionally for the students to fix it themselves. Anyways, let's see what it gives. So we have j and we have a of j. Good. Every statement ends with a semicolon. Now out of the loop, put our return 0 statement. Good. So after doing this, all you have to do is to check your work. So I look at this again. So you keep on looking, making sure that you have not made any mistake. Okay, now that you are sure, in fact, even if you made a mistake while running, while building, you're going to have mistakes. So let's try and build. You build to be sure that there is no mistake. Okay, our code tells us that we have a mistake on line 6. So let's try and understand the error. The error says I value required as increment operand. Okay, that means at the incrementation we need I, not 1. So we fix this and we comment in our question paper that instead of 1 is supposed to be I. We build again. Okay, no mistake, that means no error. Now we build and run to see exactly what happens. Okay, element 0 is equals to 100, element 1 is equals to this, element 2, element 9. Okay, so this is our output. That means there was no mistake here. Yeah, they just wanted to put square brackets and put back the number. So that's it. Makes sense. Okay, so we have our output and we know exactly what the code does. It prints numbers from 100 to 109. Yeah, using the loop. So question 2 says, what does the program do? You go to your question paper, you say the program initializes an array of integers, fills it with values starting from 100 to 109 and prints this value specifically. Alright, that's 2 marks. You could write the output if possible. Question 3. State and define the control structures used in the program above. When we look at the program, realize that it's a repetition or loop control structure. So we have to define that. We say the program uses an iteration control structure, executes a block of code. You could put the blocks of code here. This is it. Block of codes repeatedly based on the condition here, I being between 0 and less than 10, and the J being between 0 and less than 10. So these are the conditions. So we have an iteration control structure, 2 marks. Give the definition and specify. Get your 2 marks. Now the last question says print screen the output and save as screenshot. Okay, so this is the output. To print that, we are going to call our snipping tools. Snipping tool from the Windows. Click on it. Click on new. Select the portion we need to screenshot. Sometimes, guys, avoid screenshotting this part because it usually discloses the identity of the candidate. Because sometimes machines are named under the center name, like GBHS Itokebe or GBHS Mentong or GBHS Fumbot. So it's usually written here, so it's going to exactly disclose at which center you wrote. So avoid that. And most of the times, you are going to have the name of your candidate folder here. So it's going to disclose your name, and that will penalize you. So while screenshotting, make sure that you take just the black portion of the output and the execution time, so that you should be sure that you're in a terminal. So this is exactly how you should take a screenshot when it comes to programming. Okay, so everything is okay. Now we save it as screenshot in our candidate folder. So we're going to save it. This is our candidate folder in the desktop. Good. So we rename this as screenshot. Alright, we rename as screenshot and save. Good. So we are done with the question paper. Anytime you are done with the question paper, close everything. Okay, let's save it. Yes. After closing, you go to your candidate folder and you make sure that you check everything. Like your screenshot should be okay. Yes, everything is good here. You open back your code to be sure that everything is good. So it's going to open with another IDE, but it's okay. So even if you do that with FC++ or code blocks, there's no problem. Alright, so these are all the files as far as all the 3 videos are concerned. We have completed the CASPA Inter-Regional Mock 2024. That's it, guys. This is the end. Thanks for watching. Comment below for any question and suggestion. Don't forget, 1 like equal to 1 prayer, 1 share equal to 1 miracle, 1 subscription equals to 1 blessing, and all together gives 1 more video. Don't forget to contact us if you have any worry or maybe a partnership ready for donation. Just contact us at 237.nelco@gmail.com. Or you can join us in our Telegram group where we have started revision sessions. We have a content calendar for January and February. Classes are going on smoothly, and I believe all of you are getting the most insights as you can. Join us by typing this link in your search bar, t.me, Nelco Experience Computer Science, and that's it, guys. Trust the process. We move.